chemistry session. Today we will have a few more examples to practice IUPAC naming. First example, this is a coordination compound K3FeCN 6 times. So how easily we can name this compound? Let's see. The first thing, according to the rule, first thing is we have to sort out the central metal ion in the given compound. So here we have only one metal ion inside the coordination entity. So that is the central metal ion naturally. So this is the central metal ion. And then next step is to find out what is the oxidation state of that particular central metal ion. So here that's very easily we can find out. You know the oxidation state of 1 Cn or charge on 1 Cn, that is Cn minus. We usually write it as Cn minus. That means 1 Cn is carrying 1 minus charge. So here we have 6 Cn. So how many charges? It will be carrying 6 minus charges. And then outside the coordination entity, what is there? Potassium ion is there. 3 potassium ions are there. You know 1 K is carrying a plus charge. So 3 K will be carrying 3 plus charge. So here we have 6 minus and here we have 3 plus. So what will be the oxidation state of iron here? It's understood. 6 minus plus 3 plus, you will get 3 plus charge. So we have found out the oxidation state of iron very easily. So what we have to do is, first you should look into those known molecules or known atoms that is given. In that, using that charge you can easily find out the oxidation state of the central metal ion. And now we will come to naming. Everything is ready. And another rule is there. If there is a cation present in a particular coordination compound, that cation should be named first. So how should we know which is cation? It's very easy. If the counter ion is given in front of the coordination entity or before the coordination entity, that will be a cation for sure. If the counter ion is given after the coordination entity, that will be an anion. So here the K3 is a cation. Another way, you already know that potassium is having a positive charge. So that will be a cation. So in both ways, any way possible, you can find out if there is a cation present or not. Here we have a cation present. Potassium is the cation. So we have to write the name of potassium first. And then we have to name the ligand first and then the central metal atom. And here we have another possibility. You know that this coordination entity as a whole is a negatively charged entity. 6 minus plus 3 plus, you will get 3 minus charge here. That is counter or that is neutralized by the presence of counter ion here to make it 0. So this coordination entity is a negatively charged entity. It is an anionic entity. So you know that the central metal ion will be added with a suffix known as ATE, 8. So how to name? Let's see. Potassium potassium, 6 cyanide ions are there. Potassium hexa cyano ferrate. Since this coordination entity is negatively charged, ferrate, and its oxidation state is 3, ferrate 3. So that is the name of this particular coordination compound. Let's see yet another example, that is CONH3 5 times CO3 Cl. So the first thing is to identify the central metal ion. So here we have only an ion present inside the coordination entity, that is CO. So this will be the central metal ion. Now next is to find out the oxidation state of central metal ion. So here we have which known ligands and its charge. NH3 is a neutral ligand, you know, you have already learned. So what will be its charge? Charge will be 0. And then CO3, carbonate, you know CO3, 2 minus, we always write CO3 2 minus. Carbonate is having a 2 minus charge. So here is only 1. So CO3 is having 2 minus. And one Cl outside the coordination entity, that's a counter ion. Cl, you know, Cl is having 1 minus charge. So here we have 1 minus charge. So here 2 minus and 1 minus we have. So CO will have 3 plus charge. So we could easily found out the oxidation state of cobalt, that is 3 plus. And we know the names of the ligands too. This is amine and the other one is carbonato. So we can easily choose them according to the, or arrange them according to the alphabetical order. Amine comes first and then carbonato comes, A and C according to the alphabetical order. So let's start naming it. So it starts with amine, it is 5 in number. So penta, amine. Then carbonato is only 1, penta, amine, carbonato. Then what is the central metal ion is cobalt. Cobalt, its oxidation state is 3. Cobalt 3, chloride. Chloride is the counter ion. So penta, amine, carbonato, cobalt, 3, chloride. That is the name of this particular coordination compound. So it's very easy for you to name the coordination number, name of that particular coordination entity. So this is the end of our session today. We'll see you again. Thank you.